This is the first half of lesson P4, factoring polynomials. These are the factor patterns that you have to know in order to be able to do this lesson. Please pause the video and copy these into your notebook. Some people like to use SOAP to help them remember the sum and difference of cubes. The S stands for the same, which means the sign of the first parenthesis is the same as the problem. The O stands for opposite. The second sign is the opposite of the problem. And then the A and the P stand for always positive. The third sign right here is always positive. So that might help you to memorize those. When you're asked to factor a problem, you need to ask yourself the following questions. You need to first look for a common factor. Then you need to look at the problem and decide if it's a binomial. If it is, then it could be the difference of squares or the difference of cubes. If it's a trinomial, then we will use the AC method, or some teachers call it the MARF method, which we'll look at later. And finally, if it has 4 terms, then we're going to factor by grouping. Please pause the video if you need extra time to write this down. Example 1, 6x cubed minus 4x. This problem has a common factor of x, and it also has a common factor of 2, because 2 will divide evenly into both the 6 and the 4. So we're going to factor out 2x, and that's going to leave us inside the parentheses with 3x squared minus 2. This is completely factored, and we are done. Now it's a good idea to check it, and the way that you check it is just by distributing. 2x times 3x squared is 6x to the third, and 2x minus 2 is negative 4x. So we know we've done it correctly. Example 2. Again, we have a common factor. This time the common factor is 3. So we'll take out the 3, and that's going to leave 1 minus 4x squared. You always need to check and see if there's anything else that you can do. And in this case, we have a binomial, 2 terms, and both of these terms happen to be perfect squares. So we're going to use the perfect square pattern, a squared minus b squared equals a minus b times a plus b, and factor this out. The 3 is going to stay right where it is. We're not going to do anything with that. Then we're going to make 2 sets of parentheses. For the 1, we'll do 1 times 1. For the 4x squared, we'll need to use 2x and 2x, because 2x times 2x is 4x squared. And then the signs, you'll notice one needs to be a negative and one needs to be a positive. And now it is completely factored. Example 3. This is another difference of squares. This entire piece, the x plus 2, is squared, and the y is squared. So when we make our parentheses, I'm going to make them sort of big this time. The x plus 2 is going to be first, and I write it in both places because x plus 2 times x plus 2 is x plus 2 squared. And then the y is going to be second. We'll have y and y. And then we need our signs. There's a minus and a plus. So we're just following the pattern just like we did on the last one. Now sometimes you'll be able to simplify inside these parentheses a little bit more, but not for this one. We're done here. (16x to the 4th minus 81). This is another problem that has two terms. It's a binomial. It is another difference of squares. Make your two sets of parentheses. We're going to do 4x squared times 4x squared to get the 16x to the 4th. And then 9 times 9 to get the 81. And then you need a minus sign and a plus sign. The 4x squared plus 9 is done. There's nothing else we can do with that. The 4x squared minus 9 is another difference of squares, so we need to factor that a second time. Make two sets of parentheses, and then we're going to put 2x times 2x to get the 4x squared, and then 3 times 3 to get the 9, and then a minus in the middle and a plus in the middle. Don't forget to rewrite the 4x squared plus 9. And now this problem is completely factored. Number 5, this is another binomial, but this time notice the cube up here. So now we have the difference of two cubes. The pattern is a cubed minus b cubed equals a minus b times a squared plus ab plus b squared. Now, if it helps you, you might want to rewrite this as x cubed minus 3 cubed so that it's easier to see, okay, the a in the pattern is the x and the b in the pattern is the 3. And then we just substitute x every place we see an a and 3 every place we see a b. X minus 3 goes in the first set of parentheses. And then in the second set of parentheses, we're going to have x squared plus 3 times x plus 3 squared. And you do need to change that 3 squared and make it a 9. Example 6 is another cube problem. This time it's the sum of two cubes. The pattern for the sum of two cubes, a cubed plus b cubed, is a plus b times a squared minus ab plus b squared. If it helps you, rewrite that 8 as 2 to the 3rd power. So in this case, the a is the y and the b is the 2. We're going to end up with y plus 2 in the first set of the parentheses, and then in the second set of parentheses it will be y squared minus 2y plus 2 squared, which is 4. And that one is completely factored now. Number 7 has 4 terms, so we're going to factor by grouping. You need to look at the first 2 terms and see what they have in common, and then look in the second 2 terms, the last 2 terms, and see what they have in common. So in the first 2 terms, there's an x squared that we can factor out. And when we factor out that x squared, that leaves x minus 2. In the second 2 terms, there's a 3 that they have in common, but notice that this first 3 is negative, so I'm going to go ahead and take out a negative 3, and that will leave an x minus 2 in parentheses. Now you have an x minus 2 that is a common factor. Factor out the x minus 2. With this first term, the x minus 2, with that taken out, that leaves you with an x squared. And then in the second term, you're left with a minus 3. And at this point, we're done. Now, sometimes you'll have another perfect square difference of squares right here that you can factor. But for this one, we're done. Number 8, looking at the first 2 terms, we can take out a 5x squared. That's going to leave x minus 2 in parentheses. And in the second group, we can take out a 3, and that also leaves an x minus 2. So now we factor out the x minus 2, and that's going to leave you with the 5x squared plus 3 in the other set of parentheses. Number 9, this is a trinomial, so some of you will be able to just look at this and factor it, and that's fine. If you're not sure how to factor this, you can take the first coefficient, the leading coefficient, and multiply it by the last term. This is the A coefficient and this is the C coefficient. 1 times 12 is 12. And then we're going to list all of the pairs of numbers that multiply together to equal 12. So 1 and 12, 2 and 6, 3 and 4. And then we need to look at these pairs and decide which pair is going to add up to 7, which is the middle term. In this case, the 3 and the 4 will add up to 7. We actually need it to be a negative 7 because we have a negative right there. So we're going to use a negative 3 and a negative 4, and we're going to rewrite the problem as x squared minus 3x minus 4x plus 12. So notice the negative 3x and the negative 4x equal the negative 7x. Now you can factor by grouping. Take out an x, that leaves you x minus 3. And then take out a negative 4, and that leaves x minus 3. And now we can factor the x minus 3's because they're a common factor. So we take out the x minus 3, and that's going to leave you with x minus 4. Sorry about that. Now, like I said, many of you are going to be able to look at this and just be able to factor it immediately into x minus 3 and x minus 4, and that's fine. But if you don't see it immediately, this process will help you to factor it every time. Let's do one more. 3x squared plus 7x minus 20. There are no common factors to take out, so let's take the a times the c. 3 times negative 20 is negative 60. And then we're going to list all the pairs that multiply together to be 60. 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12, 6 and 10, and I think that's it. This time, since the number up here is negative, we want to subtract the pairs to find one that equals the middle term. So 5 and 12 will be the pair that we need. Since the 7x is positive, you'll want to make the 5 negative and the 12 positive so that you get a positive 7x in the middle. Now let's rewrite. 3x squared is going to stay the same. The 7x we're now going to write as negative 5x plus 12x, and then we still have the minus 20. At this point, we can factor by grouping. Take out an x, which leaves you 3x minus 5. Take out a 4, which leaves you 3x minus 5. And then take out the 3x minus 5. Please put a question mark next to anything that you would like to ask about in class tomorrow.